Okay, so next up we're talking about data that is skewed and how it's skewed. So this might break your brain a little bit. When I was first exposed to skewed data, it took me a very long time to get my head around it, and sometimes still even confuses me, and I have to actually think about what it means to have skewed data. So some of these key ideas. So symmetric distributions have middle peaks and a rough spread either side. So if you're looking at something like a bell curve, you know, it's got that peak in the middle and it's very even on either side. So this here, although it's not totally symmetrical, it is very even, and it's sort of got that sort of tail off of each side. So positively skewed distributions have a center closer to the left of the distribution. Sorry, I'm going to my left. It'll be wrong on the camera. And it's got this tail off to the right. So oftentimes, I know for me, I would think that this would be negatively skewed because I've got more of my data sort of in a negative place on my graph. But what it actually is you're talking about the tail. So if you think about it, this tail moving towards the where the score is higher is going to skew it positively, in that it's going to actually move your mean in a positive direction. So it's going to move your mean up higher and not actually give you an accurate representation of the middle of the data. Okay, so you would expect your sort of middle to be here where it has got the highest frequency, but because your score is going to be higher and these really high scores up here are influencing the data, they're going to skew it in a positive manner where your mean is actually going to be higher than where the central tendency of the data is. So again, break it down to what those scores, those higher scores, you know, and that tail of data is going to do to your central tendency. That's how I've had to get my brain around it, thinking about what it is that tail of data is actually doing. So where, you know, it's not a huge representation of the data, but because we're talking about score, it's going to be higher, so it's positively skewed in that your mean or your average is going to be higher than what your median and things are going to be. So it's going to give you a false representation of where the middle of your data is. So again, on the flip side of that, if we're talking about negatively skewed distributions, the center is closer to the right. So you've got this negative tail here, which is going to pull that mean right down and not going to give that really nice representation of where your central tendency is in your data. So when you see it like this, just think about which end is going to pull. Is it going to pull it down, which would be negative, or is it going to pull it up, which would be positive? Okay, hopefully that will get your head around not only positively skewed and negatively skewed, but actually help you understand what's going on with the data and why we call it a positive skew or a negative skew. So then we have an outlier. So an outlier is a piece of data that doesn't quite fit with our set, and it will actually have an impact on those central tendency scores and skew data. So it's something that is so outside our set that we're working with that it just almost doesn't fit. So that's an outlier, and you will go on to find out how you actually find out what is categorized as an outlier or not. But at the moment, you'll be able to recognize it because it just doesn't fit, doesn't match in. So any distribution that is skewed, so these two distributions here, should have its center described by the median. Okay, and again, we've talked about that because the mean for these two is going to be down sort of here somewhere, and that's really not a good representation of where the center of our data is going to be. So I would be using the median because that's going to be the middle number when in order, because we've got more data here and less data here, but the scores are going to be higher. So we're going to fall in here with our median. And again, the same thing with our negatively skewed data. Okay, let's move over and have a look at this graph here. So it wants us to talk about the distribution of this graph, and if there's any skewedness, if it's symmetric, and if we've got an outlier. So first up, I can see I've got an outlier. Again, it's this point here that is just not really fitting in with the rest of my data. It's off by itself, and it's going to have an impact on the rest of my data in a way that won't give me an accurate representation of what's going on. So I would categorize that as an outlier. Now, is the distribution, how is it skewed and is it skewed? So as I can see, I've got this little tail here. So I've got a really high frequency here, and then just this tail that sort of tapers off. Now, is it going to pull up my mean or my average, or pull down my mean or my average? So as you can see, the scores are getting lower. It's pulling down to a lower score, so it's negatively skewed. So it's going to pull my mean from up around here, where it would be sort of the center of my data, down. So it's negatively skewed, and it has an outlier. Okay, so let's look at these histograms. Now remember, we talked about histograms where it would be used to look at continuous numerical data, because we've got these sort of intervals in here. So it wants us to describe the distribution of each histogram. So we've got 4 here. So this first one, can you see that we've got these 2 sort of peaks, I would call them, in this data? Now, although you could look at it and say that it's symmetrical, what it actually is bimodal, in that it's got 2 points where it is most frequent. So it's actually quite difficult data to look at, and you would want to sort of break it up. But it is, it's not negatively skewed or positively skewed or symmetric, it's bimodal. And you'll probably look at that a little bit more in detail later on, but for now, just know that it's bimodal. Okay, so B. Again, we've got higher frequencies up here, and we need to look at our tail. Which way is it going to pull our average or our mean? So is it going to pull our mean up, or is it going to pull our mean down? So you can see that because this tail is moving towards the lower scores, it's going to pull our average or our mean down, so it's negatively skewed. So again, if you keep focusing on that tail and which way it's going to pull your mean, that will really help you describe whether it's a positive or negative skewness. Okay, and again, no outliers in this data. It's just got that nice clean tail that pulls that average down. Okay, so C. Again, which way is the tail going to pull our average? So it's going to pull our average up higher than where our actual data is sitting most frequently. So it's positively skewed, and it does have this little outlier just sitting out here as well. So again, if you thought about it, if you think about it, and if you used your average is going to be sitting sort of around here because of not only that outlier, but that positive skewness. And that doesn't actually give an accurate representation of where most people were sitting in terms of the score that was achieved. Okay, so break it down. Always take it back to what is the graph actually telling me, what's it talking about, and does this make sense? Now this last graph here, graph D, it's got this tail this side and a tail on this side as well. So I would be saying that this is symmetric data because it's just got a nice little peak in the middle here with a tail off each side. Not perfectly symmetric, but again, it doesn't have to be. The overall trend is that it's symmetric. Okay, so if we look at stem and leaf plots, the easiest way to do it is to actually just tilt your head or tilt the paper and observe it as if it is actually, a column graph, and work with it like that. So if I turn and look at the stem and leaf of A, I would say that it is rather symmetrical. It's probably more negatively skewed than anything, but again, overall, I would say it was symmetric. Then if I look at B, I'm going to say that it is positively skewed because we've got that tail off to the right-hand side of it, and most of our data is sitting in there, but it's got this tail off to this side. So our average is going to be pulled positively in a positive direction above where our median would sit. Okay, and again, no real outliers in that data. It's all sitting quite closely. I mean, 51 might be considered an outlier, but it's still sitting in there quite neatly. And last but not least, stem and leaf C. So again, first up, I'm going to say straight away that the 9 is an outlier. It's sitting right outside our next lowest data point, which is actually 31. And again, if you look at that tail, is it going to pull up or down our average? And it's going to pull down our average. So I'm going to say that it's negatively skewed. All right, so that's looking at skewness. Again, always remember that you're talking about the tail and how that tail is going to move that average. And is it going to be in a positive direction or a negative direction? And that's how you talk about skewedness. So break it down to what's actually happening in the graph and what it's representing.